the vertex in the equation. There is something you can see, we're going to talk about that in a second, but you cannot just look at the equation and see the vertex. So standard form up here at the top is just ax squared plus bx plus c. So if we had the vertex form and we multiplied it out, that puts it in standard form. We've practiced that with a couple of the questions that we've done. But I'm going to give you the equation in vertex form today, or sorry, in standard form today, and we're going to find the vertex from that format. So this actually, well, I'm going to give you a little tiny formula here for the vertex. So to find the x coordinate of the vertex, you're going to have to identify these coefficients. So not with the x squared or the x, but the a and b. You're going to need those coefficients to do this little formula. The x coordinate of the vertex is the opposite of b, or negative b, over 2 times the a value. So like a little tiny fraction. And then the y coordinate is what you get when you plug in negative b, or the opposite of b, over 2a. Now I'm going to draw a little thing on this definition at the top because this becomes maybe more important in some questions than others. But you have to figure out what 2 times a is before you divide the top of that fraction by that value. And I'll show you this when we get into a question because it can affect your answer being correct or not. But whatever that product is, you want to figure out that number before you do the division. Okay, now axis of symmetry, this goes through the middle of the parabola, right? And it's a nice vertexal line, so it's still x equals, and it has to go through the vertex, so it has to go through the x coordinate of the vertex, so it's actually just that opposite of b, or negative b over 2a. This will be a number. We'll just have to have the equation of the quadratic in standard form to pick out the a and b values to plug in there. Now, the b, what does the b do? All right, so up here, bx, that's the linear term. And what that does is it shifts the graph off the y-axis, being the axis of symmetry. So it's going to shift the graph left or right. I'm not going to give you any rules with this because it just completely depends on the a and b value, how it would shift it left or right. And I can't give you like a little form to figure that out. It's just going to be negative b over 2a, whatever that is. If it's right or left, if it's positive, it's going to go right. If it's negative, it's going to go left. But you'd have to know the a and b values to give a little rule for that. But what that does is it's going to move the graph left or right, so that linear term. All right, so I just wrote this again. Little summary here. Ax squared plus bx plus c. It's a parabola. The a value cannot be 0. If the a value is 0, that would wipe out the first term and you would not have an x squared, so then it would not be quadratic. So that's why it says a can't be 0. The b could be 0, the c could be 0. That would be fine, but the a value has to be some number because you can't have a quadratic without a quadratic term. This first little bullet says when a is greater than 0. All that means is that the a value is positive. If I'm bigger than 0, I'm going to be a positive number. The graph is going to open right side up. A value is positive. This was the same thing in the vertex form. So the a value is the same in standard form and vertex form, so it informs how the graph turns. If the a value is less than 0, that just means the a value is negative. Then the graph is going to turn upside down. And then hopefully by the time we're done writing this little box, you guys will memorize this formula. Okay, x coordinate of the vertex is whatever negative b over 2a ends up being when you simplify that. The y coordinate of the vertex is the value of y when you plug in negative b over 2a for x in the actual equation. So you have to have the equation of the quadratic. You're going to plug in that number for x, and the result will be y. Now, y-intercept for any graph, not just a quadratic, occurs when x equals 0. Specifically for a quadratic, if you have it in standard form, it'll be the point 0, whatever the c value is. And I know I got a bunch of letters there, but if you guys plugged in 0 for x in those first two terms, you'd be multiplying by 0. It just wipes out both terms and leaves you with whatever the c value is. That's the constant. That'll be your plain number. So you can actually see the y-intercept, where it would cross the y-axis, from looking at the equation in standard form. So we're just going to practice finding the vertex, and I'm going to have you guys write these in vertex form and standard form just to kind of relate them. So y-intercept, any graph, where it crosses the y-axis, the x value would be 0. Now, you don't have to go through and write this, but y-intercept, if I plug in 0, if I square 0, it's just 0, minus 6 times 0 plus 3, both of those first two terms just totally get wiped out because you're multiplying by 0 and you'd be left with 3. So the y-intercept of that first little equation is just 0, 3. Now, you don't have to go through and do all that work. I'm just trying to show you where it comes from. So plugging in 0 is going to give you where the graph crosses the y-axis. Now, to find the vertex, you're going to need negative b over 2a. All right, so if I've got standard form, I've got x squared minus 6x plus 3. What would you tell me the a value is if you look at that equation? Hunter, what do you think? 1. All right, what would the b value be? Ethan, I think. Yes. Okay. Now, the c value, actually, we're not going to need that for the vertex, but I was just to practice writing that. That's going to be 3 from that lovely equation. Now, because your b value is negative, the little formula, the x-coordinate, is the opposite of b, or negative b over 2a. For this question, since the b value is negative, be like negative, negative 6, or the opposite of that, so it would be positive 6 over 2a. So positive 6 over 2 times 1. So this would just give me 6 over 2, right? Which would give me 3. So the x-coordinate of the vertex is 3. Now, all you're going to do to find the corresponding y-coordinate is plug this in to the quadratic equation. Well, plug it in like a Glade air freshener, okay? So I'm going to plug in everywhere I see an x. We know the x-coordinate of the vertex is 3. I just need the y-coordinate, so we're just going to plug in a 3 everywhere we see an x. So we'd have 3 squared minus 6 times 3 plus 3, lots of 3's in here. And if you guys, this is where I would maybe just grab my calculator. You could do it by hand, but if you want to, I'm literally just going to use the parenthesis keys above the 8 and the 9, just like I wrote it on the paper. So 3 squared minus 6 times 3, and then plus 3. So my corresponding y-coordinate ends up being negative 6. So now we have both parts of the vertex, which is going to be 3 and negative 6. Now, I'm going to come down here. Let me write the formula for this just in case you guys don't remember from the other day. So vertex form is y equals a times x minus h squared plus k, where hk is the vertex. So I just found the vertex was 3, negative 6. The a value is the same in both forms. So I'm just going to plug this in. In terms of putting a, you usually don't see them write a 1 in front of that. It would just start out with the parentheses, and it would be implied that the a value is 1. This is tricky. So it's minus the x-coordinate of the vertex. So it's always going to look like the opposite of what I wrote down. So I wrote down 3 as my x-coordinate of the vertex. It looks like x minus 3 in the actual equation. The k value is just your y-coordinate of the vertex. You just copy that. So if that's negative 6, it's negative 6. This is the same quadratic, but in vertex form instead of standard form, just to practice that. Is anybody having a question? Okay. So we'll try one more example here. This one has a little bit different a, b, and c values. So I've got 1/2 x squared plus 5x minus 8. Who could tell me what would the y-intercept be for that graph? Excellent. So this would just be 0, negative 8. All right, to find the vertex, we need to know, we don't really need the c value, but I definitely need the a and b values for my ax squared plus bx plus c. What would your a value be here for this example? What's a? Ethan, what do you think? Perfect. 1/2. All right, what is my b value? Because I need that too. Riley, what do you think? 5. Okay, now, here's where I want to show you something on the calculator real quick. All right, so anytime you're trying to find the x-coordinate of the vertex, it's the opposite of b, so it'd be negative 5 over 2a, so 2 times a half. Now, I'm going to show this to you on the calculator in a second, but I'm just going to do it by hand on the paper for 1 second. What's 2 times a half? Just 1. So this should be 5, should be your x-coordinate of the vertex. Okay, now, let me show you this real quick. If you just straight up type that, like how we wrote it, negative b or opposite of b, so we did negative 5 divided by 2 times the a value was a half. I'm just going to put 0.5 to not have to mess around with the parentheses. But if you do that in the calculator follows its order of operations. So it does division and multiplication from left to right as you type it in. So it does negative 5 divided by 2, and then it takes that, which would be 2.5, and multiplies that by the 0.5. It doesn't think about how you wrote it on the paper. When you're working with a fraction like that, it's really important that you figure out what the numerator is and what the denominator is before you do the division, because the numerator and denominator, they act like grouping symbols. You should get them down to one number before you actually divide. So if I had just done 2 times a half in parentheses, that would have taken care of the problem. You should get negative 5 for that. So just be real careful. It might just be a good habit to get into if you're going to type it into the calculator and not do it by hand, which is totally fine. Just put parentheses around the bottom of the fraction, because you got to figure out what that product is before you divide the top of the fraction by that, because it could give you the wrong answer, as you can see on my calculator here. Okay, anywho, my x-coordinate is negative 5. To find its corresponding y-coordinate, I am just going to, everywhere I see an x, I'm going to plug in a negative 5. Why are we typing it that way? All right. Okay, now, little favor for me when you're doing this. Whenever you square something, it should make it positive. So if you're plugging in a negative number, you can do this by hand if you want to, or just on your calculator. I'm going to do 1/2, so I just did 0.5. Just put that little negative number in parentheses, and I'm going to square that. 5 times negative 5. Notice I'm using the negative key to put in the negative 5, but on the very end there I'm going to subtract the 8 because I'm subtracting the 8. So as I plug in a negative number, I just use the negative key under the 3. You can see it's a little bit shorter and a little bit higher than the subtraction sign. So this is not a nice number. Don't think you're doing anything wrong. It's just not. So I get negative 20.5. That is the y-coordinate that goes with the x-coordinate for my vertex. So the x-coordinate we found with negative b over 2a, and then I plugged in negative b over 2a, which was negative 5 in this problem, to get the corresponding y value. Okay, so I'm just going to write this just real quick in vertex form so you guys can see the comparison here. So the a value is the same in both forms. So our a value is a half. So if you're in vertex form, you're just going to put the 1/2 in front of the parentheses. Okay. What should be inside the parentheses? X what? Riley, what do you think? Plus 5. All right, what would you put outside the parentheses? Jonathan, what do you think? Yes, you just copy down whatever the y-coordinate of the vertex is. That'll just be added or subtracted from the parentheses. It's subtracted here because we got a negative number. The x is the opposite of what it looks like. So if it's negative 5, it looks like a positive 5 in the actual vertex form here. Okay, is anybody having a question? All right, I'm actually going to have you guys try to take it from standard form to put it on a graph on the back. And to do that, you still need that negative b over 2a. All right, so my little example at the top here, I have x squared plus 2x minus 3. What is my a value there? My a value. 1. Okay, then just checking. My b value is the 2. Okay, so opposite of b would be negative 2 over 2a. So it'd be 2's part of the formula in that denominator down there. So you'd have negative 2 over 2, which would just be negative 1. That's the x-coordinate of the vertex. once you have that, you're just going to plug it in like a Glade air freshener to the equation for x. Okay, plug it in. Don't forget, if you are squaring a negative number, just put, if you're typing this in the calculator, just put parentheses around it, because that way we'll make sure it does -1 times -1. If you don't, you might accidentally have the calculator give you a negative. So just put parentheses around whatever number you're plugging in. Plus 2 times -1 and then -3. If you want to do it by hand, do it by hand. If you want to do it on the calculator, that's what I'm going to do. So -1 squared plus 2 times -1 minus 3. Y coordinate of that vertex is -4. So if I have my vertex, if you have vertex form, we were just finding the vertex and using the pattern. We can just do that here too. You just have to do a little bit more work to find the vertex if your equation is in standard form. So let me come over here. I'm just going to plot the point -1, -4, be right there. And if my A value is 1, then we can just use that 1, 3, 5 pattern. Remember, that's the relationship between the perfect squares. So if we're working with the quadratic, that relationship exists between the points. You add 1, you add 3, you add 5 between the perfect squares. You could keep going, but with that should be plenty to get a good graph. So on either side, just go over 1, up 1. And then from those 2 points, just over 1, up 3. And it'll fit on this graph, over 1, up 5. And that should give you a really good idea what your parabola looks like. Okay, now, don't look at the graph for a second. Look back at the equation from the very beginning. What should the y-intercept be if you look just at the equation? Where should it cross the y-axis? Exactly. Okay, so 0, if I plug in 0, wipes out the first 2 terms, you'd be left with -3. So I'm just going to confirm with my graph that that's where I'm going through. If you look right here, there's the point 0, -3. So then I can use that easily to check that I graphed that correctly. Is anybody having a question? Okay, I'm just going to try a couple more with you guys here at the bottom. So really, you just need the vertex. You need the A value, and that way you can figure out what your pattern will be. And I'm just going to ask you on these questions to try and write it in vertex form as well, just to practice that. So what is my A value if I've got 2x squared plus 4x plus 1? 2. All right. How are you going to find your vertex? What would I do for this problem to find my vertex? I'm going to do that little -b over 2a. So what would you plug in for this problem to do that? What would you write in your little fraction? Hunter, what do you think? -4 over 4. I'm just going to write the 2 times 2, but he's totally right. So it's -b over 2a, or opposite of b over 2a, so it would be -4 over 4, which is -1. All right, once you have that, you're good to go. You just got to find the y-coordinate of the vertex. To do that, I'm just going to do y equals. Now, everywhere you see an x, you replace it with your x-coordinate, which is -1. And again, especially if I'm working with a negative number, I like to just plug it in with little parentheses and use my calculator to go ahead and do that. You can do it by hand if you want to, but if you just separate that out and plug it in, just little parentheses above the 8 and 9 key, it'll make sure that you do everything correctly here. And make sure when you're plugging in that negative number, use the negative key under the 3. Don't use the subtraction sign, because it won't like that. You actually get -1 for the y-coordinate as well for this question. All right, so -1, -1 is going to be my vertex. What pattern would I use to graph after I plot that vertex for this quadratic? Or would it be 1, 3, 5? No, okay. What would it be, or how would I figure it out? What do you think? Exactly. So the A value is 2. So if you want to take, you can still use the 1, 3, 5 pattern, but you got the 2 is going to stretch that graph out, vertical stretch there, bless you. The 10 is probably not going to fit on this graph, I'm not exactly sure, but you get at least a couple steps of this. But instead of going over 1, up 1, we're going to go over 1, up 2, and then we're going to go over 1, up 6. This should be more narrow than what we just graphed. What would my y-intercept of this graph, what should it be? Where would the point be? What should my y-intercept be? Rudy, what do you think? 0, 1, good. The x-coordinate has to be 0 if you're on the y axis. The y-coordinate will be a number, or possibly it could be 0, 0. Anyway, your equation here for vertex form, you'd have y equals, and then the A value is 2, so it's 2 in vertex form and standard form. So in vertex form, it would just go in front of the parentheses. And then what would go inside the parentheses if you're doing the vertex form for this graph? You have an x, right? Would it be +1 or -1? Oh my goodness, everyone's so quiet today. Would I have +1 or -1 inside the parentheses if I was doing my vertex form? Riley, what do you think? Yes. Okay, so +1 squared. Whatever the y-coordinate of the vertex is, in this case it's -1, you just write that on the outside. So we're just going to plot the point, -1, -1. All right, now I should go through the y-intercept, which is 0, 1, so this would be a way to check. But on either side of that vertex, you're going to go over 1 and then up the pattern. In this case, it's 2, 6, 10. So I'm going to go over 1, up 2, and that does put me right on that y-intercept where it's supposed to be at 0, 1. And then I'm going to go over 1 and then count up 6. It should put you at, let's see, 1, 7 and -3, 7. Going up 10 is not going to happen on the graph that we have on this paper. So that's plenty of information. I've got 5 points. In any of the tests and quizzes, it'll just have you do at least, it'll say at least 5 points. I've got the vertex and then 2 steps to my pattern, so I definitely have 5 points there. Okay, now I'm going to try one last one with you guys. Same thing, I'm going to use that -b over 2a to get the x-coordinate of my vertex. The A value in this last example would be what? I've got y equals -x squared plus 6x minus 3. What would the A value here be? Excellent, -1. Now that's going to tell you a couple things. That's going to tell you, does the graph turn right side up or upside down? It's also going to tell you the pattern for graphing this. The pattern for graphing, you just take -1 times the 1, 3, 5, and so you get -1, -3, -5. That just means the graph is going to go upside down. So you're going to go over 1, and if it's negative, go down 1. All right, let me grab, let's see, x-coordinate on my vertex. -b is going to be -6 over 2a, which is 2 times -1. So -6 over -2. The two negatives, right? Negative divided by negative becomes a positive. X-coordinate of that vertex there is going to be 3. To get the y-coordinate of your vertex, everywhere you see an x, and this is really important on this question, wherever you see that first term, it's got a little negative in front of it. It's really important that it's got like a -1. So do not put that in the parentheses. When you plug in 3 there, everywhere you see an x on that question, if it starts out with a negative in front of it, you want to do that like on the calculator. Just put a little negative, because we're not squaring -3. We're doing -1 times 3 squared. So just put a little negative out in front of that, plus 6 times that -3, and then -3. Lots of 6's and 3's. I know I just did something wrong there because I got a weird... Oh, no. Forgive. It's not -3. I'm plugging in +3. So it should be plus 6 times +3, and then -3. And I did it wrong again. Cool. Fired. All right. Oh my gosh. -3. Don't forget the 3. Should be 6 if you type that in. Okay, I should have just done that by hand. It would have been faster. All right, so this is going to be 6. Once you've got that, you're good to go. So your vertex is 3, 6. I can write, let's see, My y-intercept should just be 0, whatever, the plain number on the end, that constant term, because the first two terms would get wiped out if you plugged in 0. Should be 0, -3. Vertex form would be y equals, you'd have just a little negative out in front of your parentheses. Should be x minus 3 squared plus 6. And really, you don't need the vertex form there to graph that. You just need the vertex and the pattern. I'm just having you guys practice so you can see the two different forms. But anywho, to graph this, I'm going to do, let's see, 3, 6 is almost at the very top of the graph there. And so then I'm just going to go over 1, down 1 on either side, over 1, down 3. And then you should see this on the graph here. Over 1, if you go down 6, that puts you on that y-intercept that's supposed to be on -3. So then I know I'm graphing this correctly. Is anybody having a question?